Hey and welcome. Today we will solve word break interview question which mostly asked by Facebook as well as other companies like so. We will explore dynamic programming solutions, so without further ado, let's dive in. First example here, we have leetcode as input string and leet and code as words inside of our word dictionary. What we need to make sure is that basically to see if we can break our string using the given word. So in this case, seems like we can, because if we use both leet and code, we can create the given leetcode string with one space in between and there will be nothing left from given string. Second example basically is the same. This example just wants to notify us that we can use words from dictionary multiple times. As you can see, the result is true and there are two apples used in this case. And last example, result is false, because if we use the words from dictionary, we only would be able to succeed to create some part of this given string, not all. Let me show you. So we have cats and dog here as given string. One possibility is to use cats plus dogs, but there will be and s left out. Second possibility is using cat plus sand, but in this case there will be ogs left out. And last one will be using cats plus but again there will be ogs left out. So this example clarifies exactly what the problem asks for. We want to segment the given string in readable format with spaces only using given words, and at the end nothing remains. Let's think about how we're going to solve this. The main purpose of dynamic programming is to break down the problem into sub-problems and solve it piece by piece. It is the same in this case, honestly. Here's the same apple pen apple example from previous version of this video where we solved it by BFS search solution. Again, we will do a search of every possible combination of characters with help of start and end pointers. But the idea is this time we will have an auxiliary array which will be the same length of our string, and this array will be filled with false element at the first. We will switch those false values to true in each end index of any word match that we find. By doing so, if we check for last index in our auxiliary array and if it was true, again similar to previous solution, we might conclude that we can break this string using the words inside of our dictionary. That's simple. But we are missing one important thing here about the process of making those indices as true. I mean, you may ask, what if we have a match at the end of our string but it's still missing some characters in the middle of it? Like this example here, apple and pen. In this case, we will have apple and pen match according to the idea that we have, and the last index of our auxiliary array will be true because of pen, but we still don't have a match for and part, right? For getting you into the point, I need to explain something really important first. In order to make the specific elements as true inside of our array, that ending indices of any match that we find, we might consider two important criteria. First one is easy and straightforward. The words we find might exist inside of our dictionary. Second one is the key here. We might be sure that everything before the match we find, everything from index 0 to starting point of our match, is safe. And using our dictionary, we have already broken them apart successfully before we actually find our last match. Let me simplify it even more. In this example, let's say we are at this step. The word apple exists in our words dictionary, so first criteria is checked, but also we have already broke anything else before this, right? So we can assure that no matter what, anything else before this word was safe, and we can safely check the last index of our match, apple, in array as true. But look at this example in right here, apple and pen. When we are in pen, again, of course, pen exists inside of our dictionary, but everything else from index 0 to starting point of pen here is not breakable using words dictionary that we have. So when we want to mark the last index of pen as true in our array, it will fail our second criteria. In order to mark the end index of any match word that we find as true in our auxiliary array, we might be sure that everything else before that word was assessed by us, and we can 100% guarantee that those characters could be broken up by given words inside of dictionary. That guarantee, and only that one, will give us the green light to switch end index of our all findings as true, because like this case here, if we don't check for that safety, we might have something in between our last match and current match that we found. From dynamic programming perspective, we divided that whole string into sub-problems and ensured that we can break it up until here before getting into this point. Now detecting a new match from words dictionary becomes a bonus, especially if it happens to be the last portion in the string, because we could rely on that and say, first we will mark the end index of our match as true true in our array. And second, we are at the end of our string, so we are done with it. We successfully broke it up with given words inside of our dictionary. Again, in another way, relying on the guarantee that we have from previous portion of our string and being at the last index of string as a match, we might say yes, we can break this string with given words inside of our dictionary. One last thing before jumping into the code, if we want to mark the ending index of every matching words as true, what about the case we found the very first match in our string? In that case, we will pass the first criteria of the word must exist in the words dictionary, but we will never pass the previous portion guarantee criteria because our first index in the auxiliary array is going to be false since we filled it with false element at the beginning. There's a fix for that. We will add a fake true element at the beginning of our auxiliary array. By that, our array will be one index more than length of our string, and that very first element will be explicitly true. Faking everything before starting point was safe. With that, now let's jump into the code. So first, what we need to do is creating our auxiliary array, which will be the same length as our string, and we are going to fill it by false element. But remember that I talked about the very first element of the array should be true because of the first match that we found from word dictionary. That is why we need to create this array one element more than our string length, and that will be an explicit true indicating everything before was okay and safe. Now it's time for defining our first and last pointers for possible match. We will start by end pointer, and as long as starting point was less than end one, we will assess the possible match character by character. Now it's time to slice the word with our start and end points. After that, we need to do our criteria checks. First was if the word exists in the dictionary. Second was if everything prior to our current match was safe. If that is the case, we are going to set that matching word's end index to true in our array and break out from inner loop because we will continue within our outer loop for searching more. At the end, we will return whether or not our last index in our auxiliary array is true. But as you might know, the include method that we are using on word dictionary will give us another O of n time complexity inside of our double for loops, which will make our total time complexity to O of n3. So to escape that, we can use JavaScript set, which will give us constant lookup time. Now, if I run this, tests are passing, and if I submit, everything seems to be okay. I also want to show you one more thing before time and space complexity slides. I'll put some logs in actually 3 places. First one is here, one in here before our if check, and one more here when we find a match, just to show you the iterations that I meant in one of the slides at the beginning. Now, if I run this, and if we go into case 2, just to show you the apple, pen, apple example, now you may get a better idea of how we are checking for every possible match in our iteration here. So if you haven't still figured out how we are iterating over our string, please check this one out because it will help you out to understand it more better. Now let's jump into slides for time and space complexity analysis. For time complexity, we will have O of n in power of 2 because we've used set, not array.include, for checking if match exists inside of our word dictionary, and n will be the length of our string. For space complexity, it will be O of n, where n is the length of our string. We will create our auxiliary array based on that with one more index, which is not being counted. So that was it for this video. Also, don't forget to check the other version of this video where we used Brett's first search for implementing the solution for it. I will put the link for both that video and strings playlist in the description to check it out. Thanks for watching, and please leave a like, comment, and subscribe to the channel. And finally, hope you enjoyed this video and stay tuned for the next one.